Alright, so look, I'll get those quizzes graded for you as soon as I can. Get them in there. I will go on and tell you I have put in some more assignments in live grades for you guys. I've caught you guys up on grades as soon as I get these quizzes in. And in that, it's a friendly reminder, I won't be here Friday. I'll be leaving some practice stuff for y'all. It'll be good for you. Yes, yes, yes. Very nice. Now, we got to decide. You guys looked out? And my physics class, I ended up moving their quiz to Tuesday, and Madison and Thomas saved y'all because I wanted y'all's quiz on Tuesday, but I can't double them up. So on Thursday the 18th will be your regular chem quiz. In that, I want to make sure that you understand that that quiz will cover everything. It is fair game from what I taught you from beginning to now, excluding from here on. Nomenclature will not be on it. Nomenclature is its own beast, and I hold it to itself because that's just the type of guy I am. So you don't have to worry about it. But if you are struggling with your elements and struggling with these polyatomics, you need to study. That was 30 points. But if you don't know those, it is going to bite you big time. This is where we reach the real stuff in chemistry, and there is no turning back. I know you are all excited. I need you to hold the excitement down. So in this, start with nomenclature. You got to understand, in nomenclature, we're going to break things down in certain categories in certain ways. In this, the first thing I need to make sure you have an understanding of is the chemical formula. In these, you'll be looking at two main different types. So the first one is what we like to call a molecular formula. The molecular formula is known as molecules used for covalent bonds. Second one you've heard before. I told you a long time ago this would come back. Formula units. This and this should sound very familiar to you. Remember back when we did mole conversions? And I said if you didn't get it then, you better start working on it. Make sure you get it mastered, because if you don't, it's going to bite you in the butt. This is foreshadowing of things to come. There's a reason we're starting to use the terminology again. All I got to say. Formula units are used for, well, hold on. I need to give compounds first. They're with compounds used for ionic bonds. So now in this, a perfect example that kind of like break down everything that you could possibly see to make sure you really understand the parts within a chemical formula. So I'm going to give you a hard chemical formula here. Huh?
CA?
Yes. So in this, here's the thing you're going to be looking at. If you see a parentheses, whatever's inside the parentheses, so like the NO here, this is a dead giveaway. This is a polyatomic. Told you they'd be coming back. Didn't make it 5 minutes in class. Anybody want to take a shot of what polyatomic it is?
Nitrate.
Nitrate. Very good. So in this, on the outside of it, where you see the tube, this right here tells us this is a multiplier. You will multiply. Yeah.
Can I take a picture of Kendra Morgan for your book? Is she in this class? Sorry.
Multiply everything in the parentheses by this number. You figure out what that means here in a second. And then you have just like calcium just sticking there by itself. Okay, so in this, the important aspect to be able to know is how many of each one of these elements you have within there. This will come back later on. This is foreshadowing. So we have calcium, we have nitrogen, we have oxygen. So calcium is here. It's not on the inside of the parentheses, so we're not going to multiply it by anything. There's no number down here by the calcium. So how many calciums do you have? You have one. Good job. It's like in math. If you got X in there, but there's not a number in front of it, you know it's understood to be a 1. So look here at nitrogen. Now nitrogen's different. On the inside there's a 1. But you have a multiplier on the outside, so you multiply that by the multiplier. So you have 2 nitrogens, really. So how many oxygens do we have? 6, because we have 3 oxygens inside, but then we have a multiplier. So we have 6 oxygens within calcium nitrate. Just doing a little bit of foreshadowing there. Laying a bit of foundation there for y'all. So now in this, these are what chemical formulas look like. The chemical formulas involve the chemical symbols and numbers to tell us what's in chemical compounds and within molecules. They can all look different, and the farther you go within chemistry, the more complex they get. Any questions? You guys are doing great. So wonderful.
So what does nomenclature mean?
I'm so happy you asked. Naming stuff. That's Mr. Hall's simplistic definition. And since you asked about it, I'll tell you what we do. Let's just get rolling in it, Thomas. The first part to getting your nomenclature down right is you got to understand your monatomic ions.
We can't just name it whatever we want to.
No.
Why not?
Because then that would be all confusing. So in your monatomic ions, this is the key. These ions are formed from single atoms. So these ions are single atoms, but the key to them is that they
Mr.
are...
Caudell and Mr. Steffi are here today for credit recovery.
But the key to this is that they're an ion. This should not catch you off guard. Some of you in the room, it probably is. There are 2 types of ions. We've talked about both of them. So the first one we'll talk about again is the cation. Now we're talking about cations. Remember that which charge does that cation have?
Nelson Wartman, Kendra Morgan, come to the office.
Positive.
Positive.
Wow.
Yes. So they're positively charged ions. Now we've also looked at this before. This is where everything gets to start coming together and you see the puzzle pieces that looks of chemistry spread all throughout. It's coming together and we're starting to make the puzzle that is that of chemistry. So in that, on your periodic table, you are familiar with which columns will make cations. Which one of these columns are we speaking of?
Column 1.
That's a good one.
Column 2.
Column 1, column 2.
Column 3.
Three's from metallic bonds and they're freaky and weird. We don't deal with the D block. Sorry, I got something stuck in the throat.
You can't call that one out there here like that.
We're concerned for our health.
So
13. What's wrong with that COVID?
13.
14.
Mr. Hall, I wouldn't look at those quizzes until you're done back.
Yeah, it's not gonna help you any.
Not working there.
Actually, I think they're contaminated and you need to throw them away.
Yeah, we gotta
I
confiscate those.
leached mine. I did too.
We're just concerned for our health. It's not.
Thanks so much, guys. You're so considerate.
I didn't
We're
even
very
take out this
selfless
morning. I
people.
touched my desk. We don't want to get you sick.
I'm good, guys. Don't worry.
We're
Got a
concerned.
strong immune system.
We
You
are,
didn't sound like it.
we are concerned for your health and safety.
That
My
cough,
wife is gonna
that
kill me.
cough sounded very corona-like.
All right. So those are the cations. So column 1, okay, alkali metals. Column 2, alkali earth metals, and column 13. Those are the guys that we're looking at. They're going to form these cations. Remember, those are the ones that are forming those positively charged ions. Why are they doing that?
Because they feel like it.
No. This is the part where Mr. Hall waits on response.
Well, there comes a time in a cation's life where they gotta think more positively. And they can do that in columns 1, 2, and 13.
Maybe I should start sitting y'all on columns 1, 2, and 13 then. No.
We're not cations, it's different.
Not the reason why. Come on.
I can keep guessing, but I'm not getting anywhere.
Column 1 has how many valence electrons?
1.
So, if it wants to obtain a full octet, what will it do?
Lose 1.
So it will lose 1 electron, forming
Positive charge.
a positively charged cation. It's the same thing for columns 2 and columns 13. Now, in this, you have the opposite side. So this is like kind of like the Jedis, and then we come to the Sith, which we call anions. And what are anions?
Negatively charged.
Negatively charged. Wonderful job.
Bonus points.
Are we really
Mr.
need
Hall, you
those
don't wanna
bonus
get that
points?
police
It's not even
officer
a
in
joke
here again.
anymore.
Yeah, I almost got tased yesterday.
What?
Things happened in physics.
Yeah, Christy was cheering for it. She was like, "Get it, get it!" And I'm like, "What is going on?" I was so proud of y'all yesterday. I am not even kidding. Like I went home and I bragged on y'all to my wife. I was like, "Baby, you just don't understand. Like these kids, they were getting it." I wasn't asking them like, "What is gravity?" I was asking, "What would this velocity be?" And they're like, "Wouldn't it be the same?" And I'm like, "Oh my gosh, yes."
See, you should bring that proudness into this class and just solve that point.
Whenever y'all start answering questions like that, we'll talk about it.
Okay. Probably
Come on,
can answer
Thomas.
questions like that.
I wasn't one of the people answering the questions.
So these anions are negatively charged, and they come from the periodic table. What columns they come from?
Do they come from the freaky columns?
No.
Okay, so they're normal. 14. 15.
15, there we go. 16, nice job.
Do I hear a 17?
I got a 17.
Do I hear an 18?
No.
How about
Because what's column 18?
The end.
This isn't storage words.
Noble gases. Everybody wants to be like the noble gases, so they're not trying to give up electrons. Why? Because noble gases have the full octet, so they are no wanting to lose the electrons. They hold on to them. It's like y'all are my tight posse. I cannot let you go. You stay with me.
I'll stay as long as you give me bonus points.
God help me.
I'm gonna mix spot out of here. Oh yeah.
Paris
Okay.
is lovely this time of year.
We all in Paris?
Field trip.
No.
It can be very.
I think we should all take a field trip with Mr. Hall this weekend.
We will come together and pay for bonus points.
I'll pay for the wagon. I'll pay for your trip.
Can I borrow your hat?
Yes.
Let's start passing it around. All right, so here's the key. Whenever we're going to start naming these guys, you're going to name them based off of this, the cation or the anion. So it's very simplistic for you, but you have to keep this in mind. Whether it's a cation or an anion. If you forget it and mess it up, well, you're just in trouble. This is what we will do. We're going to break here, because I don't want to start showing you how to name the cations and get the anions. Anions takes just a little bit longer than the cations. Tomorrow, when you come in, we will pick up with this nomenclature. We're going to start rolling through, and we're actually going to start naming things tomorrow. So come in here, prepared, ready to go. Y'all are wonderful, beautiful people. I appreciate you. And I can't wait to see how you crush my polyatomic ion quiz. Woohoo! Now I'm recording. Now you can say it.
Hi, future me.
Alright, so today I have a gift for you. It's going to be a minute before we get to this.
Is it bonus points?
What do you think?
Yes.
No.
It's not bonus points.
Ooh, another easy quiz.
Why would you say that?
You want to take that?
Listen, man, I want to beat.
Do what? Tell me when you want that.
I said like when we did it normal. But I'm pretty sure it's
It's hard to hear you. You know, you got something covering your face.
I'm pretty sure it's what's this about?
Alright, what I'm giving you is not going to come into effect just yet, but the highlight is, and the hope of the day is that we get to it. So, yesterday we started on nomenclature and we got to this point where we started talking about naming monatomic ions. When we talked about it's dependent on whether it's a cation or an anion of how we're going to name it. Now, this is the thing. This is dependent on ions, so when you look at this, this is naming for
Good morning, Renegade.
ionic
The
bonds.
games for tonight and tomorrow have both been canceled. Hope everyone has a great day today.
Oh, wow.
What kind of
Everyone,
announcements?
please stand for the pledge.
I think you got your wish.
What does that mean for homecoming?
I'm sorry I
I
couldn't
pledge
resist.
allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
Okay. We'll find out later on what that means for homecoming. For now, let's get back to the ionic bonds and name these monatomic ions. So whenever we look at this, naming these ions, you're looking, it's going to fit within ionic bonds. So you have certain rules for certain ions. So, staying with what we did yesterday, I'm going to stay with blue for the cation. So let's talk about naming cation. You guys are not ready for this,
No.
No.
but it's okay.
Is it really though?
Yes.
No.
Because I don't think you can prepare yourself for what I'm getting ready to tell you.
Well, let us take a moment and ponder
Let us,
before we can.
let us take a day to think about it.
Moment. Pondering over. Okay, so in this, cations are simple. I'm just going to say simple.
Well,
Or what?
Simple.
Correct up.
I gotta admit, this is not where I thought it was going.
Shut up.
So cations are simply the element name.
All about to say, nothing in this class is simple.
This is where it can get confusing. Because there's a little trick hidden in here. So you got to think of your cations. So we discussed it yesterday, what columns these cations come from. Columns 1, 2, and 13 off the periodic table. So a perfect example, and this is where the trick can come in at. What is that?
Calcium.
That is calcium. Is milk good for your bones? Drink milk.
Do we need to know that for the test?
Once you learn it, don't forget it.
Oh, this better again. What is this?
2 calciums.
No.
2 positive calciums.
This is the charge. By the way, I didn't take off. Someone, or maybe 2 people did this on the Monatomic Ion quiz. I didn't take off for it, but I did note it for you. Some of y'all put the charge before the number. It's the number, then the charge. The reason we do that is we get the oxidation and reduction numbers, and we always put the charge before the number, so it's always a way for our chemists to automatically look and know what you're talking about. This has a 2 plus charge, which tells me this is an ion. Oh, you ain't gonna be able to see that on camera. This is an ion. We want to be very specific. It's a cation. So whenever we name cations, they are simply the element name. So guess what this is called?
Calcium.
Calcium. Going this way is not confusing. There is no trick going from this to this. Here's where the trick comes from. If I said sodium, partly, That's-
NaCl.
in a what?
NaCl.
That's sodium chloride. So you got Na, the element. But this also could be the ion. So it could be Na, and what charge would sodium form? Comes from which column?
1.
First column, so it forms +1. That's where the confusion can come in at. The cations are that simple. You're not getting any simpler. Just being honest with you. You have any questions on the cation?
So it could be Na or Na plus.
Yes, if I give you the name, you're going forward, you have to be able to give me both of them. If it's by itself. Okay? So let's go from the cations. This is where it gets more confusing. And this is where things start changing up. So we start with red, so let's keep it red for the anions. In this, they're different. They actually go through a process of a change. So when naming, you keep the root. Remove the ending. Add suffix I-D-E to the end. Anybody in here that's a grammar Nazi and wants to look and say, well, you said suffix, Mr. Hall. You don't have to say at the end because that's the ends. I just want to make sure you understand you add it to the end of it. That's where this is coming from. These are where the things change. So in this, for example, if I gave you, well, let's just stick with this one. If I gave you that, what is that called?
Chlorine.
It's chlorine. Simple enough, right? But if I gave you this, now everything's changed. I have a negative charge. It's negatively charged. This is an anion. So in this, you're going to keep the root. You're going to find this to be natural to you. Okay, so like when you get to the halogens, which are group 17, you're going to be looking at the roots and the ends. So the ends are kind of, they have a pattern. Fluorine, chlorine, bromine, iodine. In this, you can get the break that this is the end. And this is what you do. You remove the ending out. But we keep this. This is what we would consider to be our root. So now in this, we keep the root. So we're going to keep the chlor. Remove the ending, but then we add the suffix IDE to the end. So IDE. Chloride. All right? You guys okay? So what if I gave you fluoride? I want the symbol. What would it be?
F.
That's negative.
F, negative. Why do you know it's F negative and not just F?
Because it has IDE at the end.
It has the IDE at the end. That's your difference. That sells it to you. Questions?
This should be all we do today. We've made a lot of progress.
No. I got a lot more to get through.
You can't think of bonus points today?
Any chance somebody's going to drive up with a 2020 Toyota Tacoma and say, here's the title, Mr. Hall?
Yes, the Publisher's Clearinghouse.
If anybody pulls up, I'll tell you what, if anybody pulls up in that backlog with a 2020 Toyota Tacoma, 4-door,
We all get hundreds.
in a gray. I'm not giving you all 100. I'll give you free quiz.
Wait, does it just any Toyota Tacoma they want?
No. 4-door.
Okay,
Does
so
anybody here know anybody with that truck?
someone called Devonna West. She doesn't have one, I'm sure she could get one.
I'm just saying, like, I mean, that's what I keep hoping for.
I think
so
we all deserve it.
I feel like there's so much hope and faith and belief in this room for bonus points. I should believe for my truck.
Well, does it have to be yours or can just any car?
Oh, no. They gotta be giving it to me.
No, you just said that.
You just said that a Toyota Tacoma had to pull up with 4 doors.
And hand it the title.
They give me the pink slip.
You didn't say that though. It's too late.
Oh, no, I did.
No, you did.
He said, and give me the title.
That still doesn't mean you get to own it. We can give you like a copy, can't we?
My name on the title.
Well, that's what whiteout's for.
Yeah, I'm sure the court will accept that. All right.
Why wouldn't they?
So that's where we're looking at monatomics with ionics. But I want to step into a special group. So let's talk about the D block.
The D block.
Yep.
I thought we didn't talk about that.
Till now.
Dun, dun, dun. You know, if your name isn't on the title, you don't have to make payments.
I want the truck. Like, I ain't gonna pay for it. I just want the truck.
Okay.
We want to get it, and it's gonna get removed. They're not gonna pay for it.
No, they ain't gonna pay it all. Like, y'all believe me, like, y'all come in here every day thinking, I'm gonna convince him to give me bonus points.
Well,
We
no, I don't
need 'em.
think
Look at our
I'm
grades.
Not really, it's worth a shot.
I'm gonna tell y'all, when y'all get married, guys, I do not know how women have hair on their head.
You stress them out.
It might be. It might
How
be
is it possible? It's like the weirdest thing. It's like I put my shirt on and I'm like, gotta be where she does the laundry, mine and hers together. Women. All right, D block. Let's get into the D block. So the D block are freaky and weird. Just so you guys understand, are freaky and weird.
Mr. Hall, when you said we'd be naming these, I didn't know we'd be giving out insults.
It's okay. I
I
had to
spelled
teach
weird.
No, I
Mr.
didn't.
Hall, I'm pretty sure
I swear to
the
God.
E's before the I's.
Freaky and wired.
Wired
I'm
those.
still
Spanish, guys, come on. Where are those?
with those.
All right. Freaky and weird. In this.
Mr. Hall,
Hey, it was a joke, but
freaky
it's
and
not that
wired.
funny.
It makes it funny that you're not changing.
It's supposed to be funny. That's why I did it.
No, it's not.
You see the pause and you see me go, wait, what's the rule for the I and the E? I was like, okay, so make sure I get it wrong.
It's I before E except after C.
And there's not a C there, so the rule still doesn't apply anyway.
You know what? Y'all just like, y'all ruining my fun.
Don't blame us, blame Mr. Eames.
Wait, what? Oh, wait, sorry. I was thinking some other people.
I hope you don't post that on YouTube. You might get some later.
For what?
Edit
I'm
that part out.
I don't care.
You would always put thumbs down, you know?
That's
Better.
I think I kind of like Meredith's a little more.
Let's change it back.
Oh, my goodness.
Freaky and strangerly.
All right. Enough joking around. I had a girl at one time that was such a big grammar Nazi in my room. Like, she got mad that I wouldn't put commas and stuff. So I put a comma, and I pointed to it, and I said, comma. And she looked at me and was like, you know that's not how you spell that, right? I was like, yeah, I do. Like at the very beginning, when I gave y'all the metric conversion sheet, did it have coma and comma on it? Okay, well I did it just to mess with this kid. I did. I absolutely did. That probably is wrong of me and y'all think I'm a horrible human being. But I couldn't pass it up. This girl just thought that she was God's gift to mankind. It was all about herself. And I was like, I just can't not deal with this. No. Okay, anyway, so they're free. They
Weird.
can't decide to chosen what charge to be. Sometimes. I know it's weird, freaky way of saying that, but so like in this, and this is where things get very interesting. And later on, we start joining these things together. You have to be able to take pieces together. So, for example, if we took some elements like iron, let's just do the symbols. I'll have simple. Copper. What's that? Another one I got? Lead. So they will take different charges. And it just happens. This is where, like I've told you throughout this whole class, the D block are freaky. In this, iron will take on a +2 or a +3 charge.
How do we know which one to put?
It's going to be based off of what it's bonded to. That will tell you. Because it's going to be bonded to something that has a fixed charge, and then you have to work backwards. So then we got copper. Copper will be a +1 and a +2. How do you know? Based off what it's bonded to. Lead will be a +2 and a +4. So what can we do for us to fix this? We have a little trick. Now, I was talking about it earlier in class. I'm not a dinosaur like some professors that you're going to have in college. I absolutely, positively am not going to make you name off of Latin words. It's a dying, old way of doing it. If you're going to get a degree in chemistry, you're going to go through it, yes. But there's no point in making you go through it. Every professor I had that was under the age of 50 in chemistry was like, just use the Roman numerals. So what we will do to name D block elements is some parentheses. Those are parentheses. And a Roman numeral. For the charge. So what I'm saying is, like up here, for example, is some stuff that we got. So like it's iron. Then in parentheses, it has to be parentheses. You can't put square brackets. You can't just put the Roman numeral. You okay?
Mr. Hall, I'm trying to wake up.
I got you. No monsters before physics, please.
Can't make promises.
So you would put, so like for iron 2, and then close parentheses. For iron 3, it'll be iron 3. Lead 2, copper 1. If you get into a point where you don't know what the Roman numeral would look like for that charge, I will show it to you. Even I'll go to the point, you'll probably have to remind me, but on the day of your quiz when you're dealing with nomenclature, I will literally write the numbers here, and next to it I will write the Roman numeral. So you don't make the mistake of putting the wrong Roman numeral when you have it right. So like this is what I'm talking about. So with these D blocks, what they're bonded to will tell you. So a perfect example of this is iron. And what we'll see is you guys have seen rust before. All that is iron oxide. So it's like FeO or Fe2O3. Here's the key whenever you're seeing these. Look at what it's bonded to. You know iron carries multiple different charges. What about oxygen? Oxygen doesn't. It carries a fixed charge. What is iron? What is oxygen's fixed charge?
Negative. Ooh, close.
It's a -2. So 2 negative for the charge. How do I know that? Where's oxygen on the periodic table? What column?
16.
Woo! They form -2 charges. In this case, you can look at this and know. So we can start to write it down. So I can go iron, go in parentheses. I gotta find the charge. Work backwards. Figure this out. What's the charge on the oxygen? -2. How many of those oxygens did I got?
1.
So -2 times 1 equals -2. So the overall charge for the negative part is -2. We don't have an overall charge, so that means the overall positive charge is equal but opposite. So that means that the overall charge on the iron has to be +2. Divide that by how many you got. How many irons you got? 1. So you get +2. So what's the charge on the iron?
2.
So iron 2. Then take what you've already learned. There's oxygen, but it has a negative charge to it. So it would be an anion. So how would we name it?
Oxide.
Yes.
Iron.
Now if you look at it, oxygen. Keep the root. What's the root? Ox. Remove the ending. So remove the YGN.
So it's oxide.
Add IDE. So iron 2 oxide. This is why knowing your Roman numerals are so important, because you have to be able to tell the charge in that. I can work backwards and get iron 2 oxide to get to this. But look here. We got to figure out this one. So I know it's iron something. It's bonded with oxygen that has a negative charge. It's an anion. So keep the root, ox. Remove the ending, add IDE, so oxide. Now we just got to find that charge. So let's find that charge. What's the charge on the oxygen?
-2.
-2. How many oxygens we got?
3.
So -2 times 3 is -6. That's the overall negative charge. The overall positive charge is equal to that because I don't have an overall charge. I know that looks like it, but I wrote that earlier. So I have a +6 has to be the overall charge. Divide that by how many irons you got.
Yeah, but how's a +6?
Because overall negative charge is -6. So their overall positive charge has to be +6.
Okay.
Divide by how many irons you got.
2.
Plus +6 divided by 2 is +3. So the charge is 3. So iron 3 oxide. This is where you get in trouble. If you do not name anything involving a D block element with the charge, you're in trouble. Iron oxide. Which one? They're totally different. It matters. Got it? Okay. Any questions so far?
What would the Latin look like?
Very confusing. I just don't even want to go into it. Honestly, and I ain't being mean, but it's getting to the point where you're seeing the really old guys that are used to that system, that they're kicking the bucket and it's going away. Because does it matter? I look at you and I say iron 2 oxide, iron 3 oxide. It's a lot easier to understand than it is for me to look at you and say ferric oxide, ferrous oxide. Okay. Moving forward. You guys are doing good. So we've kind of combined these. Now I want to combine, I kind of jumped the gun, but binary compounds. Or let's just do binary compounds / molecules. So these binary compounds and molecules. So binary compounds we kind of already did with like the iron there. And you guys are kind of used to it. But I want to address what I gave you at the beginning of class. So I gave you this thing that has number of atoms and prefixes on it. This chart is to be used only and Mr. Hall means only with covalent bonded molecules. So if you have a covalent bond, you will use this. And only with a covalent bond. So let's review really quick. How can you tell that you have a covalent bond? What's the key?
It's bonded. With
Between
2 elements.
No. Thank you, staircase.
We have a staircase.
Red line.
Oh.
Man, I hope y'all are studying for that quiz on Thursday.
Non-metal.
Metal.
You can read. This is good. Mr. Ains is doing great. Fill in the blank.
Metal.
Non-metal.
Metal.
Water.
I'm going to throw stuff. Stop guessing.
But Mr. Hall, we don't know.
Non-metals. You have a covalent bond when you're dealing with non-metals. So it has to be a non-metal and a non-metal bonded together. This is where things can get a little tricky and a little interesting, a little dicey. Because if I looked at you and I told you I wanted you to name something, and I gave you this. Here's where things get interesting. And I pulled this one up on purpose. You're going to use the prefixes with what you would normally call these things. So in this, carbon, look how many carbons you have. There's only one. And this is the key. You will never, ever, ever, ever use mono on the first element. Now on the second element, absolutely you will. But the first element will never have mono. It's a good thing. I never have to go to the doctor for it. In this,
I just got it.
in this, you will name it by the element name. So carbon. Now, if there was a number greater than 1 on that carbon, you would put the prefix with it. Then, you go to the second one. You will always put the prefix. So what's the number?
2.
What's the prefix?
Di.
Di. You're not going to say oxygen. You're going to look and say this is normally an anion, so we're going to say oxide. I didn't get to break this down and go as far as I wanted to with it. There's still a lot more to cover. Do you guys want the nomenclature practice sheet tomorrow, or y'all want some mole conversion?
No,
I don't know how to do it.
Yeah, I think we need to go back to it.
I think you start over completely.
will mold be on my test next week?
Once you learn it, don't forget it. Always forget it.
They will.
Okay, I will print a mole conversion sheet, give you guys a couple problems. You can work together on those, and I highly recommend it. You speak for that. On it, guys, be studying for a quiz next Thursday. Okay? Last thing we need is to start off the 4th 9 weeks with a big fat F.
So are you done with the grades, like?
Will you put one of these worksheets in?
What you guys are going to do tomorrow, I'm going to throw in life grades. Okay? Okay, you can go. Remember, this 3rd 9 weeks grade is kind of more of a progress report than anything. It's not stuck in there. It's not the law.